All right, let's finish this off. We've got parts D and E. We've got another particle has its velocity modeled by the function v sub b of t, which is 1/20th t cubed minus 2/5 t squared minus 5 for the time interval 0 less than or equal to t less than or equal to 10, and for the time interval 10 less than t less than or equal to 32, 5 minus 70 over pi sine pi over 10 times t. Oof, that's a mouthful. Write the acceleration a sub b of t as a piecewise function. Well, as we've already seen in several parts before, the acceleration is the derivative of the velocity. The difference here is that my velocity is a piecewise function. So if my velocity is a piecewise function and I want to find the acceleration, which is the derivative, what we're going to do is we're going to take the derivative of the first part of the function on this particular time interval. Then we're going to find the derivative of the second piece of the function on that particular time interval and just write it all together. So the derivative of 1/20th t cubed, the power rule says bring that power down, multiply by what's down here, and reduce the power by 1. So we're going to get 3 over 20 t squared minus 2/5 t squared. Again, I need the power rule. Bring that 2 down. 2 times 2/5 is 4/5 t to the first power, or just t, minus 5. The derivative of a constant is going to be 0, so just minus 0. Now I need to take the derivative of the second piece. The 5 is a constant, so that's 0. Negative 70 over pi. I want to be careful. This negative 70 over pi is a constant. I would agree. That is true, that this is a constant. But the negative 70 over pi is a constant that you're multiplying by. And we talk about this in class all the time. If it's a constant that you're multiplying by, you just leave that constant alone. And now you multiply by the derivative of the function. The derivative of sine of pi over 10t, I said that word of for a reason. Sine of, this means chain rule. So you're going to get the cosine of pi over 10 times t. The angle stays the same, times you multiply by the derivative of the angle. The derivative of pi over 10 times t is pi over 10. Those are the derivatives. Now we need to consider the time intervals. And for some technical reasons that we really haven't gotten into much in the course, and we're not going to get into much here, is when we write the derivative is only really going to exist on the time interval 0 less than t less than 10 and 10 less than t less than 32. We would have to analyze the function differently at the endpoints than what we have done. I've also seen in the scoring rubric where if you just copied down that time interval and you said 0 less than or equal to t less than or equal to 10 and 10 less than t less than or equal to 32, that would also be acceptable. We awarded 1 point for the first piece and a second point for the second piece, for a grand total of 2 points. For those of you that are itching to simplify, feel free. You're going to get 3/20th t squared minus 4/5 t on the time interval 0 less than or equal to t less than or equal to 10. Negative 70 over pi times pi over 10. The pi's will cancel out. Negative 70 over 10 is negative 7 cosine pi over 10 times t for 10 less than t less than or equal to 32. When it comes to the free response portion of the test, there's no need to simplify, so this answer up here is just as good as the one that we have down here. Done. Finally, part E. At time t equals 20, is the speed of particle B increasing, decreasing, or neither? Explain your answer. The way that you make a decision about speed is we need to consider the signs, the SIGN of the velocity, and the acceleration at the same time. So let's find the velocity of particle B at time 20. Let's find the acceleration of particle B at time 20. Well, to do that, the velocity of particle B at time 20, we're going to go to our velocity expression. 20 is in this time interval, and so we evaluate, and we're going to get 5 minus 70 over pi times the sine of pi over 10 times 20. Remember, this question's calculator active, so if you're not sure about the computations that we're about to do, reach for your calculator. Pi over 10 times 20 is really 2 pi. The sine of 2 pi is 0. So 70 over pi times 0 is going to be 0. And what we're left with is 5. The acceleration, we said the acceleration is negative 70 over pi times the cosine of pi over 10 times t times pi over 10. So the acceleration at times 20, oh, that's a little messy, isn't that? Will be pi over 10 times 20. My apologies, let me rewrite that. It'll be pi over 10 times 20. We find the cosine times pi over 10, negative 70 over pi in the front. Still a little bit messy, I think I'm getting tired. Pi over 10 times 20 is the same as 2 pi. We want to be careful. Cosine of 2 pi is 1. So we have negative 70 over pi times 1 times pi over 10. The pi's cancel. Negative 70 times 1 divided by 10 is negative 7. Well, what does that mean? At t equals 20, the velocity of the particle is greater than 0, and the acceleration of the particle is less than 0. If your velocity is positive but your acceleration is negative, this means that the speed of particle B is decreasing. And that is the end of the question. I believe when we awarded points, we said 1 point for considering the sign of velocity and acceleration, and another point for coming up with the correct conclusion. So that brings you to 2 points for part E. That's it. Now that was a long free response question. 5 parts is normally much longer than what we would ever go with. So don't worry that you would be expected to do all of this on the unit test, but you do need to be ready to do all of these pieces, maybe in different problems. I hope you found this video helpful, and we'll talk more about this in class.